Imagine standing on the edge of Earth, looking out into the vast black ocean of space. It's beautiful, mysterious, infinite, and for centuries we've looked up and wondered, what's out there? But reaching for the stars isn't just about building rockets and launching into the unknown. It's a journey filled with danger, complexity, and obstacles we're only beginning to understand. Today, we're diving deep into the challenges of space travel, from surviving deadly radiation to keeping astronauts sane millions of miles from home. Buckle up, because this is going to be one wild ride through the cosmos. Let's start with the basics. Getting off Earth. It sounds simple. Build a rocket, aim for the stars, and blast off. But here's the catch. Earth's gravity is a beast. To escape it, you need to travel over 25,000 kilometers per hour. That's 7 times faster than a bullet. The amount of fuel and engineering required to make that happen is mind-blowing. Then there's launch safety. Rockets are basically controlled explosions. Any tiny flaw, an overheated valve, a loose wire, can turn liftoff into a disaster. Remember Challenger, Columbia? Space travel has a brutal history. Every launch is a risk, and the margin for error is razor thin. Once you're out of Earth's atmosphere, congratulations. You've entered the vacuum of space, a place where there's no air, no pressure, and no second chances. In space, your blood would boil if you weren't protected. Not metaphorically, literally. Without a pressurized suit or spacecraft, your body would expand and lose consciousness within seconds. Everything we build for space, from spacesuits to satellites, has to survive extreme conditions, brutal temperature swings, micrometeoroid impacts, and the total absence of breathable air. Space is trying to kill you every second you're in it. Which brings us to our next threat. Back on Earth, we're protected by the magnetic field and atmosphere. But out there, it's cosmic chaos, cosmic rays, solar flares, galactic radiation. These are all invisible killers. Prolonged exposure can lead to cancer, neurological damage, or worse. On the International Space Station, astronauts are exposed to up to 10 times the radiation we experience on Earth. And that's just in low Earth orbit. A trip to Mars? That's a whole new level. We're experimenting with shielding, water walls, polyethylene, even using fuel or waste as protection. But the truth is, we still don't have a perfect solution. Humans weren't designed for space. In zero gravity, your body starts falling apart. Muscles atrophy, bones lose density, fluids float upward, causing pressure in the brain and vision problems. Some astronauts come home with irreversible eye damage. And then there's the weird stuff, like your heart shrinking from lack of use, or your spine stretching so you grow taller in space. We're developing tech to fight it. Resistance exercises, gravity simulators, new diets. But even the fittest astronauts struggle after just a few months. What happens after years? Now, imagine being stuck in a metal tube for months. No fresh air, no sunsets, no friends outside your crew. Communication delays, constant danger. The psychological toll is enormous. Astronauts on long missions have to deal with isolation, depression, stress, and fatigue. One argument or misunderstanding can escalate in a way that's dangerous to the mission. NASA studies analog missions, like isolated outposts in Antarctica or underwater habitats, to prepare crews for the mental strain of deep space. But make no mistake, space doesn't just test your body, it tests your soul. Talking to Earth gets harder the farther you go. On the Moon, there's only a 1.3-second delay. On Mars, it can take 20 minutes for a signal to travel one way. That means no real-time communication, no live video calls, no instant problem-solving. Astronauts have to be more autonomous, solving issues without immediate help. It's like performing surgery with only a PDF guide and a walkie-talkie that takes 40 minutes to answer. Every breath you take in space has to be created, filtered, or recycled. Life support systems manage oxygen, carbon dioxide, water, and temperature. And if one of them fails, people die fast. The ISS recycles about 90% of its water, from humidity, sweat, even urine. On Mars, you'd need to grow your own food, recycle every drop of water, and live in habitats that can withstand radiation and temperature swings of over 100 degrees. Sustainability isn't optional in space. It's the only option. So why do we do it? Why pour billions into dangerous missions that test every limit of human survival? Because space is the final frontier. Because pushing boundaries is how we grow. Because understanding the universe means understanding ourselves. Space travel is hard, brutally hard. But every step forward brings us closer to a future where humanity isn't just a species of one planet, but a civilization of the stars. And who knows, maybe one day it'll be your name on the passenger list. So hit that like button if this inspired you. Subscribe for more deep dives into the mysteries of science and space. And remember, the journey to the stars has only just begun.